Okay, another real-world problem. So, what do you think will be the minimum spanning tree if you use the cross-call algorithm? Obviously, we start with the minimum one, right? We start with this edge or this edge. Yeah. So, yeah, this is a minimum spanning tree, correct? As you can see, every edge is connected. How are these connected? Yeah, like you can come through this one. Like that. Find the minimum spanning tree using cross-call algorithm for this one. I think it's easy. Yeah. This is also a minimum spanning tree. 2, 3. Don't form a cycle. This will form a cycle. Why? Because you see, yeah. This also form a cycle. Again, this one a cycle. And which one? This one, obviously. Yeah. Look for more insight. Can we understand more about the problem or the algorithm we use to find the solution? We can say this: if a connected graph has n nodes, how many edges will any spanning tree have? Is it possible that there could be more than one minimum spanning tree, or is the minimum spanning tree always unique? Yeah, so this one is n minus 1, right? Because we cannot create a cycle, so yeah, there should be n minus 1 edges. Especially when we have like more edges with the same edge, we can have different values. But if each edge has a distinct weight, then we can say that it will always give us a unique solution. Are these questions about the problem, the algorithm, or the solution? Or let's discuss about it in the forum. Maybe. Let's discuss about greedy algorithms a bit more. Cross-call algorithm is a greedy algorithm, like I said. And how does it work? Like it adds the edge as cheaply as possible, you know, at each step, but focus on short-term consequences. This is an important term, short-term consequences. But greedy may not work always, because sometimes, you know, this short-term greediness does not lead to the best outcomes. Remember about the students crossing the bridge problem. It doesn't work if we greedily take, you know, the fastest people on the other end. Please go back and read about our solutions and see if greedy algorithm can work for that problem. And greedy algorithm also won't find, you know, the shortest connecting flights. Okay, so there are cases where, you know, greedy algorithm may not work. So algorithms that solve this can be complex. We'll try sticking to simple problems in this course. The other greedy algorithm that we want to discuss in this lecture is primes. Primes is another greedy algorithm for finding minimum spanning tree. This is not cross-call, like I said. You have to know which one is which, guys, okay, for your exams or test. So remember, in the previous case, what we did, how did we start? We started by choosing a minimum edge, right? And then jumping from edge to edge. But here, the starting thing is like we choose any starting node as the root of the tree. By the way, the node that you choose doesn't necessarily be a node that's attached to a minimum edge. Yeah, and then so this is the first. So this is the starting point. So the algorithm goes like this. So while uncolored node exists, pay attention to the terms, guys. Okay, uncolored nodes looks like the starting node should be colored. Yeah. So while uncolored node exists, what you need to do is you probe any least cost edge that goes from any of the colored nodes. The colored node so far, like at the beginning, it's only one node, but eventually, apparently, we have colored nodes to uncolored nodes. So the edge, you choose the edge that goes from a colored node, and you check all the edge that goes out of the colored nodes, and you choose the least cost edge, E. So when you find that, what you do, you color the edge and also the uncolored node at the end of that edge. Remember, an edge is what? A line between two nodes, right? Yeah, so when you do, after you do this, you will have your minimum spanning tree, which will be the colored nodes and the edges. So in this case, which one is the greedy state, by the way? This is a greedy part. We take only the edge with the minimum cost. So in general, it means that you can think of this as like we have two different sets, colored and uncolored, or in some books, by the way, they call them also visited nodes and unvisited nodes. So yeah, we move on coloring edge, thereby creating our trees. So anyway, let's see how it works in the following slide. Oh, first, sorry guys, a homework. This is your homework. So guys, please take it seriously, okay? Please do your assignments and homeworks. So if you have any problem, you can post your question on the forum. So let's see the prime's algorithm next. So like I said, prime algorithm says that you can start anywhere, but let's start from here. By the way, you need to mark your starting position like this, in the test or exam. All right, okay. So what's the next step? The next step is creating your tree starting from here. And the first thing what you need to do is like find the minimum age that's out of, the current tree. In this case, just one node. So which one is that? Yeah, this is it. So now this is our tree and we have two edges. So you choose the minimum edge that comes out of, the tree. There are various edges. Which one is the minimum one? We have obviously this one and this one. Let's choose this one. Now we have our edges. The nodes, rather the vertices of the tree are 3. Now again, you check. So we have 3 here. Yeah, so the lowest cost edge, 3 that has a colored in node. But this is a minimum, but it will form a cycle. Remember, that's what minimum spanning tree, the definition of minimum spanning tree is. So we continue like this, then for now again we have this the different edges, edge in true meaning of a tree. So you check, yeah, there's a minimum one now because this is 5, 6, 3, so 2 is a minimum. So again, 2 is a minimum. This is the next minimum, but this will form, this is 1, sorry, but this is the next minimum, but it will form a cycle, and this is the next one. Obviously, this will be the next one. So like this. So the total cost is 25. So this is how prime works. Okay, this is another example. You can start from anywhere, like I said. In this case, let's start from here. So the minimum one is this one. And then these are this one, and then yeah. So this is spanning tree. This is so as an alternative. Let's start from the same tree, but let's start from. Sorry, this is the same thing. Yeah. So as an alternative, for example, let's start from the top left edge. Okay. So let's start from here and see if it gives any different outcome. So this is a minimum one because the other ones are these ones, and so we choose this one, we choose this one, we choose this one, because like we have the moment we reach the tree reach here, there is an edge that comes out of the tree, which is a minimum. But we don't choose these ones. We choose this one. Obviously, we don't choose this one, and the last one will be this one. So test and exam style. For example, if you are given Craskell, what you need to do is to show, which edge you have started from. So as you can see, obviously, this was the age that we started, the minimum age, obviously. Classical, that's what classical says rather, and then you continue to choose the minimum one as long as it doesn't form a cycle. So whereas if you are asking about primes, so you need to specify which node that you have chosen as a starting node, and then you will show, the solution by coloring. You remember we we have a colored and uncolored nodes and edge, so you need to color the path that shows the minimum spanning tree. Yeah, that's it, guys. Please practice these algorithms. You can create your own questions or find some question from the internet. Next week I'll come with some revision material. See you then.